The third problem in the implicit differentiation series still utilizes product rule, but in a higher degree. Welcome to differential calculus. Functions can be written in different variations. One type is explicit, which means a function y is defined in terms of x, like y as equal to negative x cubed multiplied by the binomial 3x raised to 4 minus 2. The second type is implicit, where it is the total opposite of the first. Both sides of the equation contain combinations of variables. Applying these two functions in real-life situations, you might notice that implicit functions are more common. With different variables placed together, the differentiation process in implicit functions need not be exclusive. For two variables, differentiation can be taken as dy over dx, or the other way around, the derivative of x with respect to y. We are to look for y prime of the function 1 is equal to 3x plus 2x squared y squared. Take note that the other name for y prime is basically dy over dx, so we take d over dx of the whole function. And since there is just a binomial and a constant, distribute d over dx on each. The function then has d over dx of 1 as equal to d over dx of 3x plus d over dx of 2x squared y squared. From the left side, the derivative of a constant is 0. Simplify each term a bit by placing the constants aside. So the function is now 0 as equal to the constant 3 with the derivative of x. Add to this the constant 2 with the derivative of x squared y squared. Dx upon dx becomes 1. Then the derivative in the second term requires the product rule. The function then becomes 0 as the constant 3 with 2 of the whole binomial derivative of x squared times the derivative of y squared. Then add to this the second term y squared times the derivative of the first term x squared. This expanded binomial is the product rule. Differentiate the terms within and have 0 as equal to 3 plus twice of x squared times the derivative of y squared, which is 2y, with dy over dx. The second term has y squared with the derivative of x squared, which is 2x, times dx over dx. We already know that dx upon dx is 1, and also dy over dx is tagged as y prime. So the simplified function is then written as 0 as equal to 3 plus twice of the binomial 2x squared y with y prime plus 2xy squared. Distribute the factor 2 among the binomials and have 0 as equal to 3 plus 4x squared y prime plus 4xy squared. What we needed is y prime, so isolate the term by placing it on the other side, making 4x squared y prime as equal to negative 3 minus 4x y squared. Divide both sides by 4x squared y and get y prime as the negative of the binomial 3 plus 4xy squared all upon 4x squared y. Now let's take the other derivative, although dx upon dy doesn't have any other prime name, so leave it as is. Again, Start by distributing the derivative among the terms to keep d over dy of 1 on the other side and have d over dy of 3x and also d over dy of 2x squared y squared. The left side is still taken as 0 no matter which derivative is taken, as it is a constant. Then we place the constant before the derivative. The function then becomes 0 as 3 with dx over dy plus the constant 2 with d over dy of x squared y squared. The first d is reduced to 1, but the second term's derivative needs product rule. Now let's expand the derivative using the rule. The function becomes 0 as equal to 3 plus twice of the first term times the derivative of the second. Then add the second term multiplied by the derivative of the first. The d's at this point already is near the end of the smallest term, so differentiate the function using power rule, making 0 as equal to 3 plus twice of the copied x squared times the derivative of y squared, which is 2y. Also place dy over dy with the term. Next is to add the second term y squared times 2x, which is the derivative of x squared. Then attach dx upon dy. dy over dy is then 1, so the function becomes 0 as equal to 3 plus twice of 2x squared y plus 2x y squared with dx upon dy. Distribute the factor 2 for us to eliminate the parentheses. So the function now is 0 as equal to 3 plus 4x squared y plus 4x y squared with dx upon dy. Move the term with the derivative on the other side, making 4x y squared with the derivative equal to negative 3 minus 4x squared y. Divide everything by 4x squared to have the derivative of dx over dy as the negative of the binomial 3 plus 4x squared y upon 4x y squared.